a wonderful night. There's no rain, which is incredible. It's so cool. Okay, so we have a packed house tonight. It smells okay given the size, but hopefully we have some samples coming very shortly, which are going to improve the smell of the thing. And also, it's a small room, so if you see your neighbor chatting throughout the thing, feel free to tap them on the shoulder and try and get them to quiet down. Okay, so this is DeSciNYC. It is the biggest and best DeSci meetup in New York. And what is decentralized science? If you want to find out more, you can learn more on our website, which is here, or which is on our Twitter, which is here, so you can follow us. If you have any pictures, tag us here. Instagram, tag us here. All right, step 2. So this is one of the events we've done. We've had over 10,000 people come to each of our events. We've had a lot of you are PhD students, investors, crypto people, undergrads, perfume enthusiasts. I was looking at the invite and the Luma, and it literally like 10 to 15% of people here are like specialists in the perfume industry. And I had no idea that there was that many people in New York who knew about that. So that's super cool. We've had a lot of speakers here. Okay, we have some upcoming events. There's been a lot of DeSci events recently. There's been like 3 in a row for the past 3 weeks, so we're kind of a little exhausted. But the next one will be in a couple weeks, and it's on nutrient transport and cell metabolism. This is a really interesting and pertinent topic, and a lot of people are talking about cell metabolism as being one of the most important things for longevity. Casey Means, who is now in charge of health in the government, talks a lot about this, so this was going to be a very interesting talk. If you're interested, you can RSVP here. A couple more people have their phone out. I'll give it a second. So that will be very, very cool. Oh, and also, while I take this opportunity while people are taking a picture, is if you have ideas on who would be a good speaker for DeSciNYC in the future, then you should let me know, because there's only so many people that we can think of, and at some point we have to crowdsource it and get more information from other people. So if you have ideas on who would be a good speaker, ping this here. Send us a DM on Twitter, and we'll investigate. After that, this one's really, really cool. So we had a talk on super babies by Jonathan Anomaly, and that was where you could screen children for different scores to see how smart they were going to be, the color of their eye, predispositions to different types of genetic diseases. But this is even taking it a step further, where you can, instead of just screening for different things, you can edit the genome, and so then you can actually modify it, which is going to be very, very interesting. I'm just going to jump in right quickly so that you can do this while we're doing it. We're conducting one of the largest sleep studies. Probably, we have like 5,000 people a night sleeping. If you guys want to try and contribute to the sleep study, we will give you this beautiful sleep mask later on. They actually really help quite a bit in sleeping. So if you come up to me after, you can download the sleep app, which I'm going to talk about in a little bit, here or here, depending on if you have Android or iOS. And I will give you this wonderful sleep mask. And you can be one of 5,000 people that are currently sleeping each night. It's actually really cool, so I'm going to talk about it in a second. And then also, I just want to put it out here. We're growing and we're having a lot of users. So if you're looking for a job as an engineer or a designer or a product person or a social media person, scan this QR code on the far left. We're hiring and we're looking for like talented people that are really passionate about science or passionate about design or passionate about computer science. And we have a lot of cool job opportunities there. I'll show that again in a second, but we have some people who are still taking pictures, so I'll leave it there. Any questions? Okay, so a lot of people say, what is distributed science? Like, how does that differ from normal science? And the way it works is like distributed science is where anybody can participate. Because we're seeing a lot of places where science is done in academia and in the university, but there's a lot of things changing, right? So universities are getting defunded, universities are having a lot of PhD students leave. The types of research that is being done in the university setting is also changing a lot. People think it's not as interesting. So what we're trying to do is use the crowdsourced research, crowdsourced data, crowdsourced contributions to data, and then give people equity in that. So if someone does a lot to make a research project successful, they earn crypto for that. That's sort of at the high level of how it works. So what is one of the things that a lot of people could contribute to each night is sleep. A lot of people everyone sleeps, everyone has a lot of sleep data, and right now a lot of it's siloed within Oura Ring, Whoop, Garmin, and that type of thing. So we're doing a study where people are contributing their sleep data and earning crypto in exchange for it. And we're not sort of the first ones to do this. The OpenAI, during Sleep 8, during when Sam Altman was fired, did this sleep study where they said that they checked and there was a 20% increase in people getting under 5 hours of sleep during the OpenAI drama. So this is just sort of like the first step in looking at ways in which you can use these distributed devices to conduct new types of research. Alon in the back, we can hear you up here. Alon.
Sorry, Mikey.
Okay, and then there's other things that you can do with exercise and sleep. So Whoop is doing all this research into understanding how exercise impacts sleep, and they found that the closer to exercise, the more exercise someone does when they're closer to getting to bed, the less well they sleep. But this really is a new type of research where it's using wearables, distributed, lots of people outside of a lab setting to do these new types of research findings. So the way our study works is it works with any wearable, any phone, any device. So if you have a Whoop, Garmin, or a Ring, it works. But if you just have your normal phone, we can derive a sleep score just from that by checking to see when the person last uses the phone and first uses the phone in the morning. So it really is accessible to a lot of people. And then, as I said, for each data contribution, you earn equity in the research project. And this is like a very different way of thinking about research. It's kind of like getting your name on the paper. But instead of that, you're earning crypto for this specific crypto token that's related to this research project based on your contribution. So it's kind of like a game. As you contribute to this science project, you're earning points and you're climbing the leaderboard. So you can track your points, you can climb the leaderboard, you can share it with other people. And then this really interesting thing is we're starting to do these studies. So we're looking at these minor interventions like sleep masks, like melatonin, like red light glasses, and seeing how they affect different types of people in different ways. So one of the interesting things that we're finding so far is everyone is very different. So there is no one size fits all for sleep, or I think in generally for medicine. A lot of it is actually N=1 sort of stuff. So we're starting to do these different studies where in the morning you fill out when was the last time you had caffeine, did you have a sleep mask, did you have alcohol last night, and we're building these different data sets that's very interesting. I hope to share more once we compile the data compile the data. One of the things that we found already is that the sleep quality improves a lot depending on when the last time you ate is. So the further away you can put the last meal you eat in relation to when you go to bed, the better you'll generally sleep. So again, if you'd like to participate in the study and be sort of the 5,000th one, here's the different things. We'll give you this sleep mask so that you can participate in trying out these different things as well. And also, if you would like to if this is really interesting to you, we've definitely hired a couple people from this audience in the past, so people do come. There's a lot of smart people here, so if you're one of those people, consider applying here. And well, thank you very much. And if there's any questions, let me know. Does anyone have any questions? Yes, go ahead.
Are you using the data just for the study, or are you planning on selling them as well?
Just for this study. I mean, it's just for science, right? Just for science, yeah. Anyone else? 3. Oh yeah, go ahead. I think just as long as you're over 18, it's fine.
Is the incentive within GCP for clinical trial?
Within GCP.
Clinical practice, right? There's a whole set of rules of good clinical practice.
I think that's if you're doing like a. So what's interesting is this isn't like an official clinical trial, right? This is like more like something that's more similar to a Reddit thread where people are contributing data as they would to a Reddit system. So on any Reddit thread, whether it be peptides, whether it be sleep, whether it be whatever disease you have, r/that has a lot of people doing interesting research to contribute data on that. And this is what we're trying to do is create a structured data format for sleep in this case. And so it's not a clinical trial, it's more like an internet forum. And we also don't tell people what to do really. We let people contribute and tell us what they did. So we don't want to be telling people how to improve it, but more collecting data for when people experiment at the edges and seeing how that changes the data and seeing how that changes what types of data that produces. Cool. Okay. So without further ado, we will go on to the main speaker tonight, Sean. And Sean is an olfactory expert and does some really interesting work on the intersection of AI and smell. And I'll let you take it from here.
Cool. Thank you very much. Really appreciate it. Very great turnout. Thanks everyone for coming.
Oh wait, let's get a picture.
Okay.
Everyone, smile. 3, 2, 1. 3, 2, 1, and then one this way. Okay. Go ahead.
Cool. So I have been studying kind of basically like chemical structure and the kind of olfactory impression it has, so what they call structure-odor relationships, for about 12 years. And I actually got to it from, I don't know if I can speak any louder than this.
Put it closer to your mouth.
Okay, got it. Okay, thanks. And so yeah, I've been studying that for about 12 years, and I got into it actually through art. So first I studied art, and then I, at some point, got a little bit like bored, I guess, with it, with visual art, and it kind of seemed like everything. If you look through art history, like everything's been done already. It's not like there's new colors that you can invent, and so gradually that led me to become very interested in flavor and fragrance chemistry and kind of structure-odor relationships as a kind of different space, a new space for sensory impression and a new kind of medium for art. And in particular, I'll go into a little bit of like some of my, I guess, journey to get there, but in particular, what I find really interesting is designing new molecules, designing new smells. It is an area where you can create a new color, as it were, and that's pretty fun and exciting. And in fact, we'll have about 8 different molecules for you all to smell pretty soon. So yeah, go to the next one. Okay, yeah. So just briefly, since I've got into the area, I've also done a lot of work in the food industry and to some extent in fragrance. This is and I saw this as part of my artwork actually, to basically like have an artwork that circulates in the economy at large, rather than something that's just on a wall. And I don't know, maybe we have some art people here, maybe not. Hopefully I'm not boring you. If that's not really of interest, but for me, it's something where I thought, okay, you can have an expanded definition of art. It doesn't have to be a painting. It could be a product. It could be something that you drink that gives you nutrition. This is a product that I did when I was at Soylent. I was doing flavor, work for them, and it's called Nectar. It's actually 2 molecules. The flavor of it is 2 molecules. It's citral and geraniol, and those are in a certain ratio, 2 to 1. And it's basically that is a synthetic version of what they call the nasonol pheromone. So the nasonol pheromone is released by honeybees when they mark food. So when they're kind of foraging and looking for food sources, looking for flowers that have a lot of nectar, they'll release this pheromone, And so what I did was basically take that pheromone and use it as a flavor. So it's kind of like, in a way, marketing food for humans through this soy milk product. So that was kind of one project that I did. And then, yeah, more recently I've been at Simulate. So Simulate basically simulates chicken. We're also working on some beef products. But yeah, this is a fiber spun chicken breast that I worked on and did the flavor, as well as led the team that did the texture. And then this is the kind of fibers close up. Those are about 100 micron fibers, so they very closely mimic the kind of muscle texture of chicken meat. So those are some other kind of things I've done in different companies, but what I'm most interested in talking about is my, I guess, long-standing hobby of making new molecules, and then also more recently, kind of startup called Patina that I'm working on to design new molecules and kind of decode the sense of smell. So yeah, so we'll just go ahead and kind of get right into the molecule sampling. So what I'd love to do is just use you all as test subjects, if you don't mind, and you'll get to sample the molecules, but I'd love to get your feedback. So if you scan this QR code, it'll take you to a thing called Slido. And if you have any problems with the QR code, you can go to slido.com and then just put in this hashtag new molecules, and you should be able to get to it from there. And then, so yeah, we have some very generous volunteers that are going to help hand out the scent on scent strips. And so we'll start, this is going to be molecule 1.
And if you can't hear, come to this side. I know the noise comes up from there, so there you can actually hear very well over here.
So if you do have the QR code live, I'm just going to go ahead and make this part of the survey live. So basically the first part is just describe the scent of this molecule in a few words. So you can add, as many words as you want, but just kind of keep it brief. Just like, what are the key words of this scent? And I guess for anyone that has the app open, let me know if you have any trouble with the app. It should be live, but just let me know in case there's any issues. Should be going right.
Do you guys smell anything, or
It could be subtle. Sometimes. So there's a thing called specific anosmia. So sometimes people don't smell certain smells, and this one may be subtle. So, and that's fine. If you don't smell anything, then just say I don't smell anything. But you might have to smell it like a few times. No, this one's not a beef pheromone. And I guess to try to make it efficient, we'll just, if you get the scent strips, please just like hand them out really quickly, like hand them to the next person, so that we can put in the information, and then we'll go to the next one. And if you don't have a scent strip, raise your hand and we'll try to send one your way.
who doesn't have one?
Okay.
Can you try to get some to
It's a challenging layout for distributing these, so yeah, thank you for your patience. Oh. All right, and so now I'm going to do the second part of this kind of quiz, which is, so there's two things. So you'll give a rating of 1 to 9. 9's the highest, obviously, for pleasantness. So 1 is extremely unpleasant, 5 is neutral, and 9 is extremely pleasant. And the 1 through 9 is just a common kind of sensory score, so I'm just using that because it's easy. Does that make sense? So I'm going to make that part of the quiz live right now, and then we'll go back to talk more about that molecule. What's that? If you don't smell anything? Yeah, you could, if you don't smell anything, it's up to you. You could say, I didn't smell anything and that's an unpleasant thing because I wanted to smell something, or you could say neutral. Neutral is 5. So like, if it's neither pleasant or unpleasant, then you would put a 5. And so yeah, first it asks you for pleasantness, and then then it'll go to the next question, which is the same thing. It's a rating of 1 to 9, but it's for familiarity. So if the molecule is kind of recognizable, if it reminds you of something, if it's very familiar and completely recognizable, you would give it a 9. Like that's the, I know exactly what that is. If it's completely unfamiliar, you have no idea what it is, you've never smelled that kind of thing before, then it's a 1. So you'll see both of those questions when you go into the quiz.
I assume this is the methodology you use when you test smell.
Yeah, and it's kind of developed from some standard practice, like the 1 to 9 scale is standard practice. We use it a lot for flavor and like food product development. But for me, the question of pleasantness and familiarity, if I wanted to ask 2 questions and I can only get those 2 points, those are the 2 most useful things.
And it's generally what sample size?
Yeah, usually it's like kind of like this. It'll be up to 80 people, usually sometimes 30. Yeah, the more the better, of course. Yeah. Yeah. Cool. All right. So this molecule, I'll talk a little bit about it. With some of them, I'm not going to talk about them until the end, but with this one, I'll talk about it real quick. So this is called ISO-E Super. It's one of the most widely used fragrance molecules by quantity. Part of that is because it doesn't smell super strong, and it's not too expensive, so people can use a lot of it in a fragrance and get a kind of softness or kind of enhancing effect to their fragrance. So it's kind of easy. It's easier to dose into the fragrance. Some molecules, if they smell super strong, it's hard to find the right dose, because if you go a little bit too high, it's too much. So anyway, this is a very common molecule in the flavor and fragrance space. So this is kind of like a good, almost like background sample. So this will help kind of calibrate. Oh, okay, sorry. Yeah, so this will help kind of calibrate. This is kind of a good background sample. It'll help calibrate, the scores of the other molecules. Right, but this is not a molecule that I came up with. It's a different one. All right, so now I think we're ready for number 2. Let's see. And so I'll go ahead and make that live. So yeah, same structure as the last time. It's describe the molecule in a few words, kind of the keywords that come to mind, and then we'll do the pleasantness and then the familiarity on the scale of 1 to 9. And then we have, after molecule 2, we have 2 more molecules, so 4 molecules total for this round. Then I'll just do some more talking, and then at the very end, there'll be another round of molecules, and I'll also talk about the molecule structures along the way. And by the way, if anyone has questions, just feel free to raise your hand. As long as there's not too many questions, then I'll try to get through all of them. Okay, so I'm going to assume everybody had a chance to put in the keywords, and then I'll move to the next part of the quiz. Yeah, definitely a lot of good words, and I'll give it a couple more seconds.
The audio is not as good over there as the sound, but if you go over here, it's actually pretty good.
All right, cool. So let's do the pleasantness and familiarity. So I'm gonna start that one. By the way, can you see the results when you put your results in? No? Okay. So then I'll read out some of the results too. Yeah. Yeah. If you buy like a fragrance, cologne, perfume, yeah, usually it's, some of them use extracts from plants, but I think a majority, most people would say a majority of the fragrance composition is going to be these single molecules that have been developed.
Is there like an actual price difference? Like some are more expensive?
Yeah, definitely. Similar to essential oil extracts, where rosehip oil is much more expensive than even jasmine, or definitely a lot more expensive than like lavender. In a similar way, some of the molecules are more expensive. It has to do with kind of like how hard they are to synthesize, and also to some extent if they're captive molecules. So if they're under patent, then only one manufacturer can, or one company can legally manufacture them. So that's another factor.
What about like the high end stuff, like the Chanel? Is it bullshit or overpriced?
Oh, the price. I think, fragrance, it's a luxury good in a lot of cases, so the brand is, probably more of a factor in what people will pay than the scent itself. And I think they've probably done some blind studies of what people prefer if they don't know what the brand is. So there is that aspect, but I think there are some brands that are known for more interesting or adventurous fragrances, and you do see that sometimes where others are going to be more kind of like run of the mill. So there's differences in that way, and the ones that are run of the mill might be a little bit lower priced.
Yeah, I'm just wondering is it worth paying the extra money for something that's patented or more novel?
Yeah. Oh, I see. I think as a perfumer, it could be useful, if you wanted to have a unique note. So that's where actually captives come into the kind of flavor and fragrance market a lot. Is generally it's like a large company that wants to have their formulas not be easy to copy, because right now you can break down what a formula is. You can use GCMS and then a combination of that and just smelling and trial by error to get something that pretty much is mostly indistinguishable, if not 100%. So the idea of captive molecules is it makes it much harder to do that, because if this company that made this fragrance is the only one that can use this particular molecule that's in it, then it becomes harder to replicate. Cool. So we're on molecule 2. So I'm going to read out some of the descriptions now that we're pretty much done. So here's what I have, and unfortunately I can't show this right now because it's I'm on 2 different computers. But basically, a lot of people said floral, honey, rose, sweet, jasmine, pleasant, strong, potpourri, rose grass, heliotrope, Elmer's glue, smell flowers fresh, rosy, floral, and faintly earthy, marigold, kind of citrusy, kind of flowery, and pollen and gardenia. So yeah, that's the kind of keywords that everybody came up with. So thank you for that. That's useful for me. Cool. And then let's go to molecule 3, and then we just have one more after that, and then we'll just chat some more.
How would you describe it? Do you have a set description?
Oh, okay, yeah.
You would call
Actually, I should probably let me show you all the structure too. And yeah, so this molecule, actually that's a good segue. So I'll talk about this molecule. So basically, I call it hyperfluor, and it was a molecule that I developed where I was trying to make something almost like what I would call a neon floral, or something that's so floral, so kind of planty that it almost seems like it's not natural. or just kind of like pushing it into this very extreme kind of space. And that molecule is quite strong smelling, but you can see from this kind of image here, it starts from phenylacetaldehyde, which is something that is found in rose, and it's known to be very like green, very somewhat floral, but just like very kind of green in a certain way. Not like green grass, but a different kind of green, like just like growing plants. And so what I did is basically through a couple different reactions got to this structure. So first reacted the phenylacetaldehyde with a glycerol to form a glycerol acetyl, and then oxidized that to get to this hyperfluor. And the reason for oxidizing it is that, so when you have a glycerol acetyl, then you have an alcohol group, and those tend to not be as strong in the resulting molecule than if you have either a ketone or an aldehyde. So generally speaking, if you want to design a molecule that's going to be stronger, you go with a ketone or an aldehyde. And let's see, I guess, is everyone still doing the survey? I'll come back to this in a second.
Why did you make that decision about
Oh yeah.
like one modification to make?
So from the glycerol acetyl to the oxidation, or from the just general concept of like what I was trying to make?
Yeah, like that particular modification.
Yeah, so it kind of, so it was kind of from a theory of like, okay, so phenylacetaldehyde is good, but it's in the right direction generally, but it's kind of like simple. It's kind of like one note, and if you smell it if you smell it kind of by itself, it can be a little bit like chemically, and what I wanted to do is make it more complex. And so in a sense, like making the molecule more complex helps to make the smell more complex in a very kind of simplistic way. But also having extra oxygen atoms can, so you have the kind of two oxo-ether kind of things there, and then you have the ketone. So having extra oxygen helps with hydrogen bonding in the receptors. So if they're in close proximity to the ketone, they're not too far away, because then that will change the kind of electron gradient of the molecule. But so if it's still in the same like directional basis, but then you're adding some more kind of oxygen groups, then you can make it stronger. Making it stronger also tends to make it more complex, because it just is activating more receptors. And basically when we talk about like molecules and receptors, it's usually like a given molecule is probably activating like multiple receptors, and then that gives you like the smell. And then any smell that you encounter in the world is probably like, hundreds of types of molecules that are all working together, and then it forms this kind of average. And an interesting thing about smell is like they say that you can smell about 1 trillion different scents, and you could distinguish that many different scents. Where with color vision you could distinguish probably 1 million or less. So it's several orders of magnitude, more. So yeah, so that's interesting. Okay, so did everybody get the molecule 3 yet? Oh, okay. Yeah, let's do molecule 3. Thanks. Yeah, and I guess while we're passing that out, I'll talk a little bit about this, because this comes from a kind of an art project actually. So yeah, as I mentioned, it's like my work with molecules came initially out of my art practice, and then eventually became like a really kind of full-fledged research, and then now it's also a startup. But basically this is in the kind of earlier days. This is one of the first new molecules that I made was hyperfluor. And it shows it at the Okayama Art Summit in Okayama, Japan, which was a kind of international art exhibition. And then we basically diffused it throughout the city of Okayama with these different diffusers that you can see. So that's what that is in that photo.
How much are these diluted by?
Yeah, that's a good question. Someone asked about dilution. So with different molecules, they can often have a very different strength, and they'll often smell very different in different dilutions. And a lot of times you want to if you want to evaluate them, then you want to get them to like a more average range of strength. And so these range from 20% to 10% for the most part. In one case, hyperfluor, that was 5%.
You don't know about good sense companies, like a website?
Yeah.
Oh,
Yeah. That's he mentioned the good. Is it Tim? Right. Yeah. Tim mentioned the Good Sense Company, which is a good resource if you want to kind of look up molecules and what they smell like. They have some information. There's some other databases out there, but yeah, the Good Sense is pretty good for that.
The website looks like Captain.
And they're not updating it. The guy that made it, I think he made it in the like 90s. He was just like really into
Makes
it.
sense.
Yeah. So he was a web designer, I think, first, and then he was like, why don't I make a website about smell? And then he just like started putting it all together. And I think a lot of perfumers still use it, or especially when they're starting out. Yeah, myself very much included.
It was like broken out web and they fixed it.
Oh right, yeah, cool. Yeah. Cool. All right, so I think we're pretty good on descriptions for molecule 3. So I'm going to switch over to pleasantness and familiarity. And then we'll have molecule 4, and then we'll be, done with the molecules for a little bit. Thanks, everyone. Yeah. That's a very good question about pleasantness.
Continue to talk a little bit. Yeah.
Okay, well we'll just do the last molecule of this group, and then, because we're going to talk a little bit about the structures and stuff. Cool. And then, really quick, so I think you all have rated it mostly. Great, and then let's do molecule 4, and then we'll go into the talk. I'm trying different formats, like sometimes I'll do the molecules all at the end, sometimes at the beginning, but I think it's kind of abstract if you're not if I'm just like talking about them and then you're smelling them later. So yeah, so we're trying it out.
All those molecules you invented, right? Except for the first one.
All molecules.
You invented all the molecules about the first one.
Yeah, that's correct for this group. Let me look and make sure. Yeah.
They're not ISO-E, right?
So none of us,
Yeah, ISO is the first one, so that's not me.
so
Yeah.
none of these we've tried before.
Yeah, and I'll get into the details of those in a little bit, yeah. Cool, all right. I'll kind of like do some of the talk though. So this is a kind of early artwork that I did that first got me into flavor and fragrance chemistry. And basically the idea was to come up with the chemical difference between Coke and Pepsi as a...
Guys, let's quiet down a little bit.
Yeah. We're gonna try to multitask, so I'll try to like talk while you're evaluating a little bit. So this is a artwork that I did, kind of early one that got me into flavor and fragrance chemistry, and it is basically like the concept is it's the difference between Coke and Pepsi, but it's the actual like chemical difference. So like if you added up all the molecules in Coke, all the molecules in Pepsi, and you kind of figure out like what's the Venn diagram there, what's the difference that Coke has that Pepsi doesn't, that Pepsi has that Coke doesn't. It's that calculated chemical difference as a substance. So this was like a just weird art project, but in the process of doing this, I did a lot of GCMS analysis of Coke and Pepsi, of the flavor, and started seeing this relationship between structures and odors and doing a lot of research. And so that's what like first led me into this area. And then, yeah, this is an art exhibition where it's basically different molecules. Each of those containers is a single molecule, and they're arranged by kind of structural features into a grid. So you have methyl methanoate, which is the lightest molecule. It's like a carbon, it's like a methanol esterified with formic acid, and so it's the lightest. And then in the bottom right, you have butyl butanoate, which is a 4-carbon, butyl molecule esterified with also a 4-carbon, and so it goes in this kind of grid. So this idea of like structural relationships and like being able to smell those differences, and sometimes like putting them all together, kind of averaging it out in order to get to some sort of almost like general odor arising from the specifics of the different molecules. That was a kind of a way that I was working in these projects. But then, yeah, the first new molecule that I made was around the time of that other exhibition, which was 2014. And it was kind of a modified version of hydroxycitronellal. So if you're a perfumer, you might know it. It's kind of like a floral, they call it muguet. It's like a kind of white flower, lily of the valley. And the interesting thing about it is that it's one of the very first completely synthetic molecules. So they were able to synthesize vanillin and some other molecules that are found in nature before then. This was in the, I believe, late 1800s, either that or the early 1900s. And but this is the first fully synthetic molecule. This never existed in nature. And the only thing is, it's pretty interesting. And they say that it captured kind of lily of the valley better than the extract, which is, basically you can't really make an extract from it. So that's interesting. But what I wanted to do with this modification, which is down here, is by adding a silicon atom, make the molecule more flexible, so that this kind of aldehyde group and then this alcohol group can get in closer proximity, which then theoretically is going to activate the receptor better. And so, I've tried with some different chemical companies, and they were not able to make this molecule. But I kind of kept it around in the back of my mind, and eventually came to this other molecule that you see here on the right. So even though this one doesn't really have that feature of the alcohol group at the other end, it does have an extra oxygen atom, and it does have the silicon atom that gives it kind of a lot of like bulky interactions. So just kind of like mass that can interact with the receptor in a hydrophobic way. And yeah, so that this molecule does actually smell kind of like a supercharged lily of the valley. Yeah, and we don't have that molecule here, unfortunately. Sorry. Yes? Yeah, so the silicon, it's not a heavy metal per se, but it's a great question. We do a toxicity screening. It's basically in silico, actually several in silico toxicity screenings for any structure that we come up with, and what we anything that I have synthesized is going to be like safer than the average fragrance molecule that's in use today. And silicon is in a lot of cosmetics, like in dimethicone. It's by itself, it's not toxic in this sense, like a low toxicity in comparison to other molecules that are used in fragrance. But yeah, it's a very good question. Yeah. Cool. And I think yeah, again, multitasking here, but I think we are ready for the really quick. We'll just do that last molecule's pleasantness and familiarity, and we'll get that out of the way, and then we'll move on.
Why did they not have the alcohol on the left side? Why did they not synthesize it?
It was a long time ago, so I don't remember exactly what they said. But yeah, I talked with a few companies that were specialized in silicon, organosilicon chemistry, and the one that got the farthest said that they couldn't do it in the end. I think it was just either unstable or it just didn't produce the reaction that they thought through the pathway that they selected.
But does that change the scent crazy?
Yeah, so if you try a version of hydroxycitronellal that doesn't have the alcohol, then it will be pretty different. it's more just like green grass at that point, and a little bit more like if you just took that alcohol off, it's like a little bit citrusy and grassy, and it's not very white flower, like floral. So it probably does play a big role, but here, for whatever reason, this molecule, which is kind of almost like a rearrangement of that other molecule, it does have the kind of blue as a valley note. There's a lot of accidents. So like you think that you're making this molecule that's going to smell this way, and then you're always surprised. But the longer you do it, the more often you do it, you eventually find certain kind of your intuition gets better. You're able to kind of do a better job. Cool. So the last molecule is actually, so when you were asking the question about if there's other molecules that I didn't make, so the last one that you just smelled, I didn't make that one. That's called hedione, or also known as methyl dihydrojasminate. That's also another very popular fragrance molecule. So I wanted that as another benchmark, and then we can kind of see like where the other molecules stack up. But some of the words, someone said transparent, powdery, hedione. Someone got hedione. Who got hedione? Who got it? Who got it? Okay, okay, yeah. You're a perfumer, so yeah. But whoever said transparent probably knows what, probably is familiar with hedione because it's kind of famously transparent. Someone said coffee, which is interesting. Pepsi. I think that was probably because I was talking about Coke and Pepsi. Because that is the power of suggestion, or if you see something at the same time that you're thinking of it, there's a lot of like cross-modal kind of talk in the brain, and so you probably did smell Pepsi, but it was maybe for another reason. And then someone said velvet, soap, friendly, vanilla, crisp. Someone also said nothing, floral, super, detergent, shampoo, wax lemon, pine sol. So that's what we got there. Cool. Thank you. All right, so I'm going to just continue on. Oh yeah, and this is, just continuing from this project. This is a installation that is also in Okayama. It includes that scent, and then also there's some mutated morning glories that I grew in this pool area. But I'm going to skip through a couple of these things actually. Yeah, so here talking more about structure. So this is a project where I put together kind of analogs, so molecules that have kind of similar structures but not quite the same. And I basically made like a fragrance out of those analogs. So each molecule in the fragrance is similar to the next one. And the idea is to try to get to that like averaging effect and try to get to like a general sense of a particular type of molecule, but without all the specifics of like this molecule, that molecule, that molecule. It's kind of like a blending. And so this was in this exhibition. There's these diffusers on the wall, and these are some of the structures, and I kind of laid out the structures and showed kind of where they overlap. So these are the components in this particular mixture. Here they are superimposed, and then this is like the common structure down here. And then a similar thing with this group. So each of those scents, each of those diffusers was showing like one of these. Like so this one, and they're kind of I'm kind of like playing around with them in different ways to align them and then make a fragrance that is kind of abstract fragrance arising from those different chemicals. And then actually here is something kind of similar to hyperfluor. This structure has the phenol structure, but it's different in that, so for example, this one is the alcohol, where hyperfluor is a ketone. So it has a stronger and kind of like more full smell. And then another thing is that I put predicted olfactory activity. So this was in 2018, so I think the predicted olfactory activity was, kind of iffy, but there was a research group in Shanghai that had this thing called odor actor. So I was using that to predict the olfactory receptor activity for all of these. You can see a little bit of that there. So this is kind of like one series of molecules that I've done, and you smelled hyperfluor, which is this one. You'll smell another one of these towards the end, but there's this kind of, it's basically a motif, this kind of structural motif where you can take an aldehyde and then turn it into a glycerol acetyl, and then oxidize it, and then you get this. And it generally makes the smell more like multifaceted and stronger. And sometimes it changes it specifically or significantly from the parent molecule. Other times it just kind of enhances it and makes it stronger. And yeah, so lately I've been doing a lot more with like receptor modeling, using AlphaFold and some other tools. And the thing with olfactory receptors is the structure is not very well characterized. There have been some receptors that were characterized with cryo-EM, but generally we have 400 different types of receptors, and we don't really know that much about the actual kind of folding and function. But with this some different tools, I've been working with a kind of simulated in silico version of the receptor, and then kind of docking different molecules onto it. And that's pretty fun because it's almost like a collaboration with the receptor, where you're kind of trying to get a better score, get a better binding affinity by adding an extra carbon or like moving this or that around, and then you try it again. So that's been another kind of direction that I've been doing in terms of molecular design. So there's the kind of more structure-based approach, and then there's the receptor-based approach. And this is a molecule called E12, just to show more of the kind of electric field and different aspects of it in 3D. Cool. And here's a bunch of other molecules. These have a common motif of like a dimethyl group or a terpyl group. So these little branched structures. They smell pretty different, but there's some similarities. And I would say, thinking about molecule design here, it's the kind of dimethyl group is more of like an accent. So instead of the dimethyl group being like the word, it's more of like an accent that you put on the word. And so compared to the molecule that doesn't have the dimethyl group, it generally makes it more full and maybe more complex. And then, so I'll just talk a little bit about Patina, which is a startup that I'm working on. That is basically, our goal is to decode scent, and in particular make a lot of interesting, cool scent molecules. And we're using these kind of in silico techniques and some machine learning as well. Basically kind of trying to come up with like what are the primary colors of scent, and then trying to, longer term, trying to understand the entire olfactory system from that basis, but starting with a kind of more receptor-based approach initially. And that's the team, my co-founder, Laura Sisson, and these we grabbed from our deck. But the other thing that's pretty interesting is ectopic olfactory receptors. So once you kind of are modeling the receptors and you're kind of finding very good olfactory molecules that bind to them, you're essentially doing, drug development. And what's interesting is that there are drug targets in the body that are olfactory receptors. There's what we call ectopically expressed receptors, which basically, you have all these receptors in your nose. You have about 400 different types, but those are also expressed in different tissues, and they have specialized functions, but for the most part, those are unknown. It's a relatively recent discovery. And these are generally, like, olfactory receptors are not well understood or explored by, the pharmaceutical industry. So that's another reason that, they're pretty interesting. And so basically, if you're developing, scent molecules, there's a good chance that it might also have another function if you find the right place to deliver it to in the body. And that's kind of what we're thinking of long term with Patina, but in the short term, we're focused on, just better understanding these receptors. One example though is there's a certain receptor found in skin that when it's activated, it is involved in wound healing. So it speeds up wound healing and kind of skin regeneration and potentially rejuvenation. So that's something that we're quite interested in, like, further exploring. And we have, so based on our in silico studies, we have actually a molecule that we've developed that has a binding affinity of -10 calories per mole, which is quite good. And compared to like a kind of known odorant that's an agonist for this receptor, it's about 190 times stronger. Now, again, these are just in silico numbers, so like we do have to validate that, but that's kind of where we're at right now. Cool, and then, so yeah, here's just a little bit more info about ectopic olfactory receptors, and then this is kind of like a chart of like where they're found throughout the body. So you can see quite a lot of different ORs, olfactory receptors, and here they are in the adipose tissue, in the lung. This one OR2W3 is found in the lungs. These were all coming from just sequencing, sequencing DNA in these different areas. So you can see it's like they're quite widespread, even though we know very little about them. And I guess if you think about it, it kind of makes sense because, okay, so the nose is like a chemical sensing organ, so it has all these tools, these little switches that respond to different molecules. And your other cells also need to understand their chemical environment. So if they're coming from the same genome, if they're working from the same kind of toolkit, then they'll express the same olfactory receptors, but just use it for a different purpose. So it kind of makes intuitive sense. But yeah, again, like right now, not much is known except for in a few isolated cases. But yeah, so I think basically, discovering the primary colors of scent is very fundamental actually for human health, for the future of human health, and that's something that we're very excited about at Patina. And so with that, so that's kind of the last slide. Do you all want to try 4 more molecules, or do you want to just like not try 4 more molecules? I see some yeses, and I see some yeah. Okay. What I'll say is like if you're feeling up to it, then let's do it. And then if you're not, then yeah, you can just like go get a drink or whatever. That's fine too. I don't want to hold you against your will. But yeah, otherwise, yeah. And I guess real quick, any questions? Yeah.
Can you tell us what was in 3 and 4?
Yeah, 3 and 4. So 3, yes. Let's go to one of the image slides. So 3 is this guy. Yeah, that one right here. And so this has a dimethyl group. I showed it in that slide with the other ones with a lot of dimethyl groups. Now 4 is hedione. So that's not a molecule that I invented. It's a very popular molecule, similar to isoe super in the level of use, and it's just on the more floral side, where isoe super is more woody. Yeah.
Are you using any kind of headspace as a starting point, like where you're capturing the existing scents?
So we don't do too much of that. I mean, I've done a fair amount of like GCMS headspace in the past, but what we're working from is usually pretty much just like synthetic. It's just like, okay, we'll have an idea for a molecule, or we'll be going over like the kind of chemical space and like and realize, okay, this part of the chemical space is kind of like underrepresented, and let's take a look at that. So we're mainly starting from that kind of starting point. Yeah. I'm sorry.
How long and how much does validation
Validation of like the olfactory receptor. So yeah, so if it's a, so we have kind of like 2 workflows. One is like the general, just kind of structure-based workflow. That one, it's just you just synthesize it and you smell it, so it's like quite quick. For the other workflow where we're looking at receptors and we're starting in silico, the validation, we have yet to validate that in the lab. So we're in the very beginning. But once we validate that in the lab and see that there's a correlation with what our kind of like predictions are, then we can actually do the rest of the development much more quickly. And that's because we'll know that, okay, if we're getting to this kind of direction from a sensory point of view, then that means that it does correspond to a certain receptor activation pattern. Yeah, that's right. Yeah, this is a great question. So about the pleasantness and then the familiarity. So actually the reason that I'm interested in those 2 things, pleasantness is obvious. Like generally you want pleasant molecules that are, especially if you're designing them like for a business. But the familiarity is where I think it gets interesting. And I think you pointed out that they tend to be correlated. We tend to like sense we tend to think that scents are more pleasant if they're more familiar, but there are times when that kind of diverges, and that's what I'm most interested in. I think that's where, okay, well, that means that we found like a new smell that also has maybe some commercial potential, that has a kind of interesting sensory kind of profile. Yeah.
Have you seen that drug by DeSciNYC? That's like an olfactory drug. I think it's like the DeSciNYC or something.
I think I've heard of this, and it may be, it's going towards the vomeronasal receptor, I believe, and it's kind of based on a hormone, I think, maybe.
Yeah, it's something to like trigger your amygdala.
Yeah. They say that there's like a direct pathway to the limbic system through this one olfactory receptor. I think that's another like interesting area, and that's pretty much, along with the ectopic olfactory receptors, there's the connection to the limbic system. We know that scent is connected, but it's a question of like, can it be connected at like a single receptor level, or is it more just like this kind of, is it more complex? Like, can you reduce it down to like just activating one receptor causes one effect, in the amygdala or just in the brain? So, I think that's a very interesting area. Yeah.
Like, I don't know if you're familiar, there is like some theory that the structure of the molecule is not enough to explain like the scent, and that you need to know also how the molecule vibrates, and there are like more effects. Like one of the latest exponents of this theory, Turin.
Yeah, Turin. Yeah.
I'm curious if you're taking into consideration this theory, your simulation in field, or like which is your opinion?
Yeah. So, I think so. Luca Turin is, he has like a lot of very good ideas. I think the jury's out on the vibrational theory. I think the majority of people or majority of scientists would say, no, it's more of just like, traditional pharmacology almost. We have the receptors after all, and so, they respond to ligands in a similar way. I would tend to believe that personally, but I think at the same time there is something still a little mysterious about it. So maybe Luca Turin is onto something, in exploring that vibrational theory and this kind of electron tunneling. From what I've read, I haven't heard like very strong validation of that. But if that's true, then you could, I don't know, like you could activate receptors with certain photons that are like at the right wavelength, which is pretty interesting. But so far, in terms of the kind of development of our molecules, it's all just in silico using traditional like docking methods, traditional like pharmaceutical methods.
Like how do you measure that in silico, in your simulation, that a molecule works with a specific receptor?
Yeah, so it's a little, so I mentioned about the binding affinity, so we have a method for predicting binding affinity, but it's a little bit more complicated than that because with kind of olfactory molecules, there's usually some sort of key amino acid interactions that involve hydrogen bonding. So you might have a molecule that binds really, really well, really strongly, and it's all hydrophobic interactions, and then you'll find that it's actually more of like an antagonist. And it's blocking the receptor, so you do have to keep that in mind. So so we do have a prediction for binding affinity, and that's what, like, if we're iterating in silico, then we're aiming to just increase that and increase that. But then we also look at we also have a prediction for the amino acids that are being interacted with, and we're looking for some certain key hydrogen bonds in certain areas. Yeah.
I was going to ask a similar question about vibrational there's been research that suggests eyes can detect whether a computer or not.
Right.
I was going to ask you if you believe in that, or do you think it's just due to, like, I think I chatted with a professor when I was still in school.
Yeah.
And he said the reason you can taste clear water as more sweet is because the autoionization constant is lower. So
there is.
What do you
I think that there is some. Definitely, I think there's something to that, and I think also like I don't want to reduce like what Luca Turin is talking about to just one thing, because I think there's a lot of other like there's a lot of unexplained phenomena in olfactory perception, and he's pointed them out and come up with good explanations for them. Like one thing is like that I think I read this in one of his books, but it's like if you are under a pressurized atmosphere, like similar to like if you're scuba diving, then you can actually smell methane, and it smells camphoraceous. But it has to do with like the pressure, and so under certain pressures, then you will be able to smell molecules that you wouldn't otherwise be able to at atmospheric pressure, and that's maybe a little bit like the mechanism is maybe somewhat similar to this kind of deuterated molecules as well. Yeah.
This is a question for the people in this room that are like not brilliant chemistry or experts like some of you are. Some of us are here as just like hobbyists or like fans or just interested. So pausing on like the molecular thing for a second. I'm just curious on like your company, your process. So like I'm following with like the molecular structure, but I'm curious about your process. Like, are you given a brief and then what's the end goal? As we're talking about receptors, like what is it that you're trying to? Is it that your goal is like a manipulation of a sensory experience, or like and then who is giving you directives like design?
Yeah, that's a great question. So I mean, we're a startup, so it's like very early. But I think what we're imagining is a few different things. One is, I mean, we're going to design our own molecules. We're already doing that, and we're going to release those. But the other thing that we think is very interesting, we haven't done quite yet, but we're starting to do pretty soon, we think, is work with perfumers to develop a custom captive. So, give them their own captive molecule. So rather than it being just the purview of like very, very large companies that have these unique molecules that only they can have, working with a perfumer to identify like what's a note that they find very interesting and would be useful to them, that they would use a lot, and then make that like an exclusive captive to them. And that requires that the molecule be under patent, or at least pending patent, turning into a patent. But yeah, that's an idea that we really want to explore, and we are talking to some perfumers about that. But then the main thing is right now is just molecules. In fact, we're going to start selling some on Perfumers Apprentice. I don't know if you're familiar with that, but we're going to start selling a small kit of some of our molecules, some of the ones that you smell today, on Perfumers Apprentice fairly soon. And longer term, this ectopic olfactory receptor is something that we see as like an outgrowth of what we're doing with the other molecule stuff, and that has other applications outside of fragrance potentially. So we're looking at like a cosmetic application, but that is going to be further down the road. But yeah, a skin cream that contains a molecule that activates the receptor in the skin that causes it to regrow faster and kind of rejuvenate. That requires some validation before we get to that stage, but that's one possible application that we're looking at.
You guys use a lot of like brand canvas and stuff, but I use a lot of perfume language. Then you also talk about, changing molecule becoming full, making the scent more full.
Yeah.
So I'm curious, do you traditionally stick to like the perfume repertoire, or how do you kind of translate these more abstract, like very concrete molecular structure changes, but more like abstract perfumery changes?
Yeah. I think it's always a struggle to describe how a molecule smells. And I'm kind of interested in like trying to develop other language that's not so referential. So like in the English language, we can only say that something smells like something. We can't say that something is something with smell. So like for example, you can say the sky is blue, and blue is like a specific color that has a specific receptor in the eye that it corresponds to. But you generally don't say that like a scent is something. You say that it's like something. So it's like a rose, or it's like or it's minty, which is another way of saying that it's like mint. So I'm going off on a little bit of a tangent, but I think in terms of like how to describe the molecule and the nomenclature, I kind of use whatever words kind of work, but then I know that they're never quite right, and that's like I think what keeps scent very interesting is that it's like it's elusive to language. You can't quite pin it down. And as much as I get all these like words and kind of numbers from all of you, like it's not gonna, it's just a kind of low resolution reflection of like what the molecule experience actually is. But in terms of like the structures, like the visual structures and the kind of, which relate to the 3D structures of the molecules, you know, there's kind of like little, like I was trying to talk about it being a little bit like a grammar. And yeah, like here, like, so here it's like, these are different molecules and they smell, each one smells pretty different, but they do have these methyl, these kind of either tert-butyl, which is like a 3 methyl groups, or they have 2 methyl groups. And the methyl groups are just these little carbons that are coming off of the main chain. And yeah, I see that as like, by itself, that wouldn't even have a smell. So if you just smelled like a tert-butyl, kind of like carbon arrangement with no oxygen, like it probably wouldn't have much of a smell, if any. But when you attach it to another molecule, then it becomes almost like an accent, and it tends to make that molecule, tends to like push it, either push it in a certain direction or just like make it a little bit stronger. And so for me, that's just been like one of the tricks that I kind of use, or something that I tend to fall back on when I'm designing molecules. I have like some of my like kind of favorite things to do, like when I'm kind of designing a structure. Yeah. Sorry, so that's what I do.
So when you're talking about like defining the like color spectrum of smell and almost like sort of piggybacking on that, the thing that comes to mind for me is synesthesia. I'm wondering if you've done any work with people with synesthesia, or like thought about that, or.
Yeah, I think that's very true. I think I have like a very mild synesthesia with like smell and other things like music. It's not like I think there's like involuntary synesthesia where like you can't really help it. You're just gonna, like if you see the color yellow, you smell toast or something. That's one type of very, you know, specific synesthesia. But I think on a lower level or on a more common level, yeah, there's a lot of people that have that in some form, and I tend to like picture things or have a kind of like feeling, like when I'm like smelling a molecule, I have a kind of like feeling of it. I think a lot of people in their language to describe the molecules used certain terms that were not exactly referential, but like, you know, like velvety or transparent. Like I think those are almost like synesthesia terms. You know, they're not talking about, you're not saying it smells like a window, you know, that's transparent. You're saying that it provides a transparency. And yeah, I think that a lot of, there have been some studies that like cross-modal language can be a good way to describe smell. So borrowing from other senses, basically. But yeah, it's a very good question. Yeah.
So your data set for historical simulation data from like browser apps, so it's just limited to humans, or like you can.
Oh yeah, that's a very good question. It's just for me. It's just for this one. It's just limited to humans. There have been some studies where they created what they call consensus receptors from combining the DNA sequences of multiple species, and they were able to better express those in some other organism. But yeah, for us, we're just interested in the human receptor.
Does the weather like affect the smell? Like if it's a high pressure day or high humidity or something like that?
Yeah, definitely high humidity affects it. Heat generally is going to make the molecules come out and kind of, you know, come into the air. Pressure probably affects it. I'm not sure. I assume it probably, if it's high pressure, maybe they're coming out less. But on the other hand, it tends to be humid when it's high pressure, so it probably comes out on balance, maybe more.
I think when it's high pressure, you inhale more air molecules, and when it's hot, it's low pressure, I think.
Okay.
So
Yeah.
I don't know if that made a difference.
Yeah. There's definitely like effects from the atmosphere, like for sure. Yeah.
Because you're talking about the scuba thing.
Oh yes. Yeah. True. Yeah. Theoretically, if you were, under a super high pressure environment, then yeah, you would smell things differently. At least according to this study about methane.
That makes sense.
Yeah. Cool. Any other questions? Okay. Yeah.
Have you think about using AI to measure specific discoveries from these markets that you're working on?
Yeah, so we're definitely, using AI. I guess you can define AI in a few different ways, and in one sense we're using just traditional like machine learning. I guess in the other sense we're using like AlphaFold and the kind of like 3D physics-based kind of simulations, and I guess both of those are a kind of AI. So we basically use both of those. For the structure-based approach, there's a bit of like intuition, and then we're kind of using some machine learning to boost that. So it's kind of like this stuff that I was doing already with designing new molecules, but then trying to cover more chemical space and amplify it using machine learning.
Do you need how to like predict like a certain molecule, what that would smell like, or the classic certain notes, or is that like something that's like maybe pretty
Yeah, there's some open source things for that, and it's kind of interesting, but like I always find that like the language, it's like I'm always just mostly interested in pleasantness and familiarity, because I think the language can be elusive and there's lots of different ways to kind of label it. But I think theoretically it's like interesting to know at least in what direction, if it's like a green note or a kind of sulfurous note and things like that. But yeah, definitely I think it can help. It can help with the prediction. So far, I think we're in a point where it's more like helping to search the chemical space for interesting things, and then we'll screen those things, and then refine the model based on that. Yeah.
Sweet. All right, I think that's good.
Okay, yeah, maybe that's the last question. Okay, we'll talk after if anyone has
Sean will be
questions.
around after.
I'll be around.
If you have more questions.
Yeah.
Let's give Sean a round of applause.
Thank you. Thank you. Cool. I guess like for people that really, I would say for people that really want to smell the other molecules, and that's great. Then just come over to this section, and then for anyone else, feel free to mingle. Yeah, we have some more molecules if you want to smell them. Yeah.
And if you
Thanks,
want a
everyone.
sleep mask, come over here
yes.
and get the sleep
Yeah.
mask as well. Thank you guys.
Cool.
All right.
Thanks, everyone.
No, they're not. They're just normal ones.
Actually, I want to mention one more thing before people break. So at Patina, we're looking for some excellent chemists to join us. So if you know a synthetic chemist that actually does, synthesis of molecules, then yeah, we'd love to meet them. Thanks.
I think it's possible that I haven't produced anything that does that. But yeah, theoretically, I think you could. We go through a toxicity screen to make sure we don't accidentally produce something like that. So we use this like predictive machine learning to say if it's something that could be bad for the lungs, if it could cross the blood-brain barrier, we synthesize it, or if it's within a certain range, then synthesize it. Yeah, I feel like I know something. I'm always interested in smell to see how it smells, but I know some people that, if it looked like it would have a psychedelic effect, they would probably try it. Because I'm looking for something. Very cool. Thanks. Yeah, for sure. What was your
So what is this thing?
How universal is smell?
Maybe over 18.
Oh, hey, yeah, thank you.
I'm working on this. Like I never really I do not look at the brain, but I read about not through the notes, because my thesis was on quantum biology. So I know not quantum biology, in the same how you can if there would be as I know in activity, I can picture the debate. If it's for me, biology.
Sorry, excuse me.
like is there like this technical like I'm assuming that you are focusing on the luxury.
Yeah, that's accurate. Yeah. And we haven't unlimited this so that's the thing. So like integrated. But and then we get this thing back and it has a synthesize it. So you can still screen it now, but if you're screening it on we're actually like we're like doing that validation.
Oh, thank you. Nice to see.
Okay, this is strong.
Oh, yeah,
This is very.
It could be a lot. You can talk to him a lot about breaking the tape. Literally just want to be like, oh, got it. Yeah, good stuff.
Oh, perfect.
Yeah, thank you so much.
You got the head, you Yeah, you smell it in the I think we're going to add that to like 3 or 4. I'm talking with Travis. Hopefully within a month. Right now, we're trying to look yeah, we want
But like he invented this protocol, right? So is there
like for example, is that made by
Oh yeah, you could. Yeah, you could.
I was talking about like use that.
Oh yes, like you start with the yeah, it's like an esterified. Yeah, no. I wanted to hear your talk. I think they're talking. Yeah, that's all right. I already talked.
I don't really see any like practical needs.
Like also too. Maybe there's a way to
Like he would like
sense it.
like it's not like like find a job. It's not many jobs. Yeah, I guess flavors and or it's like so little just
We all have. Yeah. Is it related to the look of there was a question.
like to get
The first phase is kind of basically producing like the best fragrance molecules and then selling those to at first perfumes and then just larger companies. Like there's a few companies that control most of the market. Juvenile, and so basically like if the molecules are not able to transfer, then we can sell them to the larger ones later. So that's kind of like the top market. And then so we have like right now we have like 5 pending patents on different types of and also
Thank you for
I wonder about that too. Like I wondered, like theoretically, if you had unlimited time to research, you could go and just like add different molecules. But actually, you can't really because it's like you can not know how many of them, but like the space of possible molecules is like astronomical. Like it's there's more possible molecules than there are atoms in the universe. So the combinatorial like space is huge. That being said, I think the olfactory space is small. It's somewhat more self-contained. And then so almost like you have like the set of like molecules, and then within that you have like olfactory molecules. And then within that you have like good olfactory molecules and then pockets here and there. So finding the pockets, I think there is a bit of a race to that. Although large companies are not like they're not moving that fast. I'm not aware of like there's this company called that was doing some like stuff with AI.
Did you get the app?
I'll do it in a second. This thing
I don't think there's that many people like trying to really
I don't know. I was reading against it. I don't know. Let me download it right now.
Okay, yeah.
Thanks, Mikey. Stadium. This one. Yeah.
Right. Right. Totally. I think also it's like interesting because the open source gets a little bit with perfumers because they actually want something that can't be copied. So it's like in that's they need like a so it's like my general tendency is like open source is good, but then it's like very easy for like a large fragrance company to copy like us.
I grew up
Cool. Yeah, that'd be great. I'd love to chat. Cool. All right, nice to meet you. Robert. Nice to meet you. Nice to meet you. How are you guys different from Osmo? Oh yeah, so I might try Osmo version here. So I guess different background. I think I started out being really interested in molecules and then kind of like how to design them for fragrance. And I think they started out being like really good at machine learning and then being interested in molecules. So like we kind of ended up in the same place, like where they put a lot of machine learning into it to then get to the point where like maybe a guy that's like, been studying it for a long time. But I think for me, I'm kind of trying to kind of boost what it is that I do with AI. But I already know how to do the thing. So that's the kind of it's more like enhancement. That's kind of how I do it.
Then there is that method which he was trying to check
Within certain range, and a lot of times I'm surprised. But so we have a model that predicts the smells with like
No way.
but then also if I look at something like I can have a general sense of how it smells, but then I'm also surprised like 30%. There's so many surprises.
Thank you for your talk.
Yeah, thank you. Appreciate it. Nice meeting you.
Actually, a little bit about like day-to-day operations. It looks like you conversation.
So it's a startup, and it's right now it's part-time. So day-to-day looks like nights and visits. But usually I'll be doing one of two workflows. One is going through kind of design molecules,
speak. Yeah. And I think
Selling them, and then be able to close it insulin mode.
oh, of course, when they see that they and actually it's funny
And where you Manhattan?
No, in Brooklyn.
Oh, okay. That's awesome. Which state of weather are you guys?
Precinct. Yeah, we're just starting.
That's awesome. That's so exciting. Let me know. I might be down to next year.
Yeah, that's great. Like, I think we're pretty early, so I'd love to have just like have someone that's like investing, I can start telling. I just like this week
Yeah, no, but what I've been into that we're trying to fix now is having like actual real people. Put in some money just so that when you do something, you know what I mean? It's like actually pretty nice. Yeah. And so you'll put in 1,000 or something, whatever. Something like that.
After we raise,
and then publicly.
Cool. I'll put you on the.
Yeah.
And so we're raising 750, and then so like we get there then 10K otherwise.
Yeah, I mean, I think it should be like great talk.
I'm very interested about the skin study.
Yeah, I didn't mention that this is where competitors are
but I was like kind of thinking, should I not?
That's all right.
Because like we have Cosmo people here.
So that's all. One really feeling is like stuff right now. We had someone who was scores their service we were working with Score, they're back into work. So now they were like willing to do it. And so now we have to like recuperate it. So I know it's fine, but it's just like we're doing through like a lot of just like little dumb things. The biggest problem is hiring. I've been here for 4 months. My younger are you to your job or? Yeah, I work in the flavors. Oh, that's why. This is the connection.
This is what you do regularly. You also do
The lab that I worked at, well, like I was a researcher and actually, I was an admin. I mean, I'm really happy that this is like a after work and everything because like I have a job. I'm busy this week, but like maybe next month.
We can always use more. The one that we were we need more. Yeah, that's great.
I didn't do.
Okay.
It's no rush anyway.
But yeah,
I can always No, I live in Jersey.
Oh, you live in Jersey? Okay.
I transfer me. I gotta get home.
Oh, yeah. Okay.
I'm thinking about hosting these events. Yeah, I was your first or second. I went to the AI and government. Oh, cool. I'm gonna keep going to these. I was gonna ask you, like, what's up with the membership? Like, guarantee. We're gonna start charging. Okay. For them, just okay. But like, I think like $50 or something, and then we'll do like a membership for like. You can buy like a cocktail. I just want people to be here with intention, more so than anything else. That makes sense. It's not to monetize it, it's just more like filter. It's a lot of work to like also makes it more people always
So, but
So what I just put it there.
you guys are very important. I'm like, wow, this is.
He comes to these. Oh yeah. Like I was talking about that. Like you were like, okay, what's
And
up?
the other side.
I don't know. Yeah, it's just for fun.
Because we
It's just me, but it's almost. Do you want to help volunteer, or? I mean, kind of. I mean, if I have time, sure. You just read our work. Do your own Telegram. Oh yeah, I'll use it. We're like photographers, photographers,
I met a guy there that was like, oh, I'm going to do something cheaper. Yeah, I was better. I get their hair stuff done.
Oh yeah. Are you all from the fragrance?
Cosmetics industry,
Cosmetics?
packaging, a
Oh,
chemical
okay.
engineer that should have done this.
Oh.
I went the other, I
Okay.
went process engineering,
Yeah.
I used to make bounty.
Oh, cool.
So, and then I got into Estee Lauder, I did 10 years, I used to do, pick and place robotics for the assembly line.
Oh, so cool.
I bought CNC machines, so I'm like a weird Pokemon that nobody's ever heard of. Yeah, you know, and I'm getting a refresher. Tomorrow I want to like crack open my old Oreo books. I've forgotten a lot of these.
I see you out all the night.
I might need to take an edible and look at the carboxyl groups again. That's what horizon. I think that's what revamped chemistry is. Terpenes, right? And all of the chemistry.
I'll send you them, but
And the
what I was
sense of
trying to get at was like,
fragrances in that world also is right a lot of pine, lemon, and all these interviews. Did you say if you need a connection with Julian or with like one of those kind of places, if you wanted to connect them, because that was my universe for a little bit.
That's great.
I mean, these are big commercial guys, right? But they got the big pockets, right? And I know they're probably trying to do, you know, a lot of really amazing, like more sustainable upcycling.
I got it.
Yeah.
All right.
Excellent.
if I send Maria to sign in.
Right, there is, yeah. Because we screen everything before we send the session. We screen it for ecotoxicity and
I've been really trying to make it effort.
and all of that.
So much more technologically advanced, and I like that there's like days in the lab, so I want my hats off. We were just sitting around trying to figure out what ketones were. Which one is this?
Love that reading.
Oh, sorry. It's a mix of both. We have the computer side and we have the human side.
Yeah, well, I imagine the
Do you have an understanding of Instagram
modeling
versus
hasn't
life
changed in
now?
all these
Right.
years.
Recognize
now the ability to like match things, right? It's kind of like you're able to like predict.
Okay, I'll remind you in some way.
And this lady is amazing to know as well.
I come from another world. I work in the blockchain space. The blockchain space. I do crypto, I do different.
Where do you live in the city?
Stuff in the chain, I tokenize.
I just moved to Williamsburg. I hate it.
It's terrible.
That's too far away. You're gonna come here, I was like, yes, it's too far away.
Yeah. Like they have this like automated
I
DAO.
lived in West
I think it's
I lived in West Village.
But it just reminded me, we're talking to them about the pre-seed but tribute.
Oh yeah.
Yeah, you have your. I have a friend that works there, so yeah. Or it's not automated. Your nemesis. Okay. Yeah. True.
And they all go around pretending like marketing.
Yeah. At least I was fine. If they did what?
Okay,
Oh.
And I was like,
Wow.
they just invested.
Yeah.
Yeah, they have quite a, quite like on their website, they have quite a range, you know, like some stuff, I guess maybe by chance you can fall upon some good stuff, but then like also have like not great stuff too.
I live in Manhattan. I'm going to
But yeah, this was
Por eso yo voy a cantar.
That's so great.
That's a plan.
I hope my question about
No, that was a great question. You know, let's be tangible here. What's the product kind of thing? That was very helpful.
I have friends in LA.
No, because I
My
was
friend is LA, she's American.
I'm like sitting over
And before me coming here, she said, this is very bad, I don't know why are you coming, I want to leave. I'm so excited.
everything you're saying.
Yeah, what is the company? The practice is
The thing is, I
quite
don't know.
new, and so it's like kind of just evolving out of this process. So it's like we're kind of like have like
It's different.
different possible avenues, you know, but the first one is molecules.
No, I mean,
Getting into the field.
I need the level that
I just want to thank you for
Oh, thank you. Oh, I appreciate it.
Yeah, I used to
What's the last one? Yeah. Oh, okay. Cool. Oh, okay. Cool.
So this is the first time
I'm saying
Oh yeah.
Yeah.
You want to know what? Like, so the hair doctor makes the shampoo.
Right.
We wanted to make some candles for.
Because I think it's like.
Yeah. I mean, I think our main thing is we want to make the molecules to make tips. But then for some of them, you know, some of the molecules could have a skin cream effect. So that would be like the second stage of the company. Like, so first we make the molecules that have very good smells, but then we can take some of the learning about like and then use that to design certain molecules that activate receptor skin.
I understand if I do this kind of
So that's like the next stage.
So yes, I understand what you're saying. Maybe I have some.
Yeah, we're already planning for that. We're not designing a couple molecules. Right now we're raising money to
the recent ones are
kind of further develop that and then validate it. Oh yeah, so the validation of that particular receptor. First, we need to. There's a couple different ways, and we're kind of still researching like what's the best way. But we could definitely have like a CRO, so it's like a kind of contract research organization to do a test. They can do it.
co-founder of
Yeah. So correct. So in this case, we're focusing on a cosmetic where we're not making that it has like but we're going to publish the science.
Oh, okay. So yeah, Maria.
So we're kind of like trying to
Maria,
be in the space between like fragrance and by being in the cosmetic space. So in the cosmetic space, you can have an active ingredient that can be kept secret, and you can have an active ingredient that is not going through clinical trials. So that's much less regulation. But you can still put the product on the market, and then you can publish the scientific research, and then people that
with Big Basel is really
yes, this works in this paper, and then try it out. Yeah, so we're trying to like find a different channel. You know, that's not as difficult as like the
co-founder and
oh yeah, exactly. Yeah, we're trying to start small, trying to get the product on the market right away. That way we can also iterate. So like we're already starting to supply it to consumers, and then going from that, then we go into cosmetics after we're like stable. Yeah,
I love to connect.
Oh, yeah. Oh, okay.
You guys are married.
Yeah, cool. Yeah, including like chemical ingredients.
Yes. I actually.
Yeah, that's right. That's like a Canadian. Yeah.
What I do, but
my effort is just to say.
Yes, actually. Yeah, I have WhatsApp. Yeah. And I also think WhatsApp.
Like some women that are in venture capital, they have So I hosted meetings with them during Denver.
I have like a simple.
And we partnered up with
Oh yes. Okay. I'll do that. Okay.
It's kind of like the first and maybe only group that I knew about DeSciNYC. They're kind of like building it very slowly.
About a year. I mean, I've been designing molecules for like 12 years. So I've been doing the functional fragrance part of it for 12 years, but the startup, the team, and then
Sorry, I didn't mean to interrupt you.
I wasn't. No, that's fine.
for sure.
The reason we go this goes faster is because we.
Okay.
So I think
Faster. Yeah, that's so funny. Yeah. Same language.
Try to do it with like other people, and they're like.
It's just really Latino, so you
Very funny. Yeah. Right. How I operate like. Yeah.
Yeah, actually. Yeah, I'll have one.
How about this? I don't know if you have any
this
plans
weekend.
to buy me
I have too much information.
But in my radar, this
Alright, you gotta
is
cut it down.
DeSciNYC, which is like
You
too much
like all this
time
technical stuff, but
in the industry. It's not political, so I have to be. But there's also provision.
Thank you so much for.
So it's gonna be a lot of people in crypto. So I was gonna say I'd love to maybe have people host it by the end of the month. And I can help you.
Yeah, and if you can find a venue that has good.
Right.
I mean, I know all the problems, right? It's just because here and there's not enough seating, but I kind of like it.
No, it's good. Yeah.
It's a good, but then we do need better structure.
Yeah.
I just need to figure it out.
Okay, I can help you figure that out. I did the same during that week. I hosted my thing at the 70 Beauty Labs. 70 Beauty Labs.
Oh, yeah.
Space, very nice. I guess they're not charging you. That's for me because of next week. But if I go again, they're going to see like, okay, fee or something. Let's see, maybe I can cover it. So maybe we can figure out ways. There's also Pace University. There's
Yeah, and some
okay.
I didn't try my friend tried it. They were like,
okay, so I knew they were in LA, right? Like that's where I first.
they were, and then like, there's
Oh yeah.
No, we can figure it out. I can try to put it together if you agree. So let's figure out the date. Let me. So do we exchange numbers?
What's that?
What do we exchange?
I know. Yeah. There's like
Text me.
or there's one that's.
There's like the official one.
There's a couple different ones. Yeah.
Right. So like my challenge.
For room to everything is so expensive. So I'm like joking. If you know of anything.
I know people.
Really nothing luxury. Something simple around town. Like it doesn't have to be Manhattan either. But like
I
shopping here
applied.
and there.
Well, I visited school and they were like, you're
And then that was something that I want to have. Sorry, if I'm planning to say and then yeah, I love
like I would have thought they would be
together
bad.
for the like I'm not gonna be here, but they can take care of everything whatever. But I'm really leaning into the venture capital
Cool.
Help you there.
Very cool.
Yeah. Congratulations again. Yeah.
Congrats. Good to see you. Good to see you. All right.
So my question that I asked about like where I'm from, why I made it, about
So basically, like, not yet because we're kind of just starting. Yeah. So like, actually, the week before last, I was in LA for the thing like 10 weeks, and it's put on by a lot of perfumers go there. So I did it there's a lot of people interested, but there's two things. The one is that that just kind of started recently, so I have to get stuff together to like get it out to them. But then the other thing is like two of the molecules, it's hard for us to synthesize them. So we have like 6 or 7 that we can send out. There's a little bit of a bottleneck. But anyway, yeah, starting to like send out samples to them, and yeah, I've talked with 2 perfumers about like they tell us, yeah. So basically that, yeah. So they would tell us like a note that they think is missing. I don't know if it can be so. At this point, I don't know if it would be so specific as like to answer like, but like if it's like words, like we can send maybe like 10 molecules that we think are in that direction, and then they can pick like the best 2, and then like send another iteration, so that we can have the idea. And then out of that, then they would get like a molecule that's kind of just their own molecule. So it would be hard for, and that's assuming that we're all
You know when you can tell that there's something there so I think this is something. I know you have another that. Oh, that's the entire like I mean, it's my team, really busy. And they know that we're gonna be sitting down with the family because my team are friends. No, and I asked
so
them.
it's more like a stage. Like so I think the first stage, like the easiest kind of way to get things to set up there is to talk to that are part of the larger companies. And then we do want to work up to where we're licensing ingredient. Yeah. So like we would just give them these ingredients. We're developing our own brand and all that, but like the brand is not really. It's more like B2B, So that would be the first stage, and then we do want to work up towards licensing some of the molecules to our. What we think the best way to do it is just to get them out there in the world and get people excited about it.
Okay, so we're in that combination.
Nice to meet you.
I'm curious if like I work
Yeah, I've heard of them. Yeah. So, sure. That's fine. Actually, there was a guy from Osmo. I know some of the people from there. He was here.
Well,
There was a guy, not the CEO, but like
rent for 200 1 hour. I do the pictures.
he's a tall guy.
This is my lifestyle.
I'm tall. Well, I guess like my most, I'll do some look in it, but like I do like them in general. Okay, sure. But basically, like I think so. The way I started, there's like 2 different journeys, and I think we're in similar space. But
we can discuss all
Right. Yeah, I mean, I think recently they pivoted, some of them pivoted to just formulation, and then like fulfilling small orders, or like fulfilling small orders, or like designing fragrances with low MOPs. So I know that that's like their main pivot to just, I think probably to have them new and just see if they get traction that way. So that's a little bit different than, at some point they were looking more at molecules, but from talking with people there, they've kind of pivoted away from that, which is great for me because I've been looking at the you know, I've been kind of working on these models for a while. So yeah. But we'll see. Maybe they'll give it back. But I guess basically the difference I think is maybe the approach to AI. I'm kind of like I've learned, you know, how to do this stuff that I was really interested in, and it has like kind of almost like a form. And then I'm just using AI to like fix that and accelerate that and kind of like expand it. I think they started where they do, you know, AI programming. Didn't really know about fragrance. Maybe were interested in fragrance, but didn't have that same background. So they had to build up a whole system to get them to the point of like maybe what a perfumer was. And then there's kind of teams to build that. So I think it's like a difference of how we got to where we are. And also, going forward, foremost interested in molecules and then trying to build factory system, which is a large task, but we want to do that through the receptors. I think they're focused on, to the extent that they're kind of thinking about the model to like predict how companies smell. It's not necessarily which they so I think that's a difference.
Yeah, you can hear it. Yeah. I think I'm going to try a new venue.
What I'm trying to remember, I'm like, when I understand, like, what are the spots, I think I don't even mean like in the present of what's possible, I mean like, what's your thoughts, like big ideas in your strategy of like, you're like, this is what my size and like, receptors like, do you see this as like, is it just like sensorial? Yes.
I think what to me is like, I mean, I think that there's definitely because we do have those receptors in the body, and that's how a lot of drugs work today. But they haven't used them on the olfactory.
Okay, perfect. That would be great.
So there is like a whole.
I work a lot, so I have a lot of things.
You know, it's something where if you fully understood the receptors, then you could introduce different scents. You could have like, you know, for example, like a oh, bye, nice to meet you. You could have like a almost like virtual reality like thing. You know, something that I thought was pretty interesting. And you would need to know how to like compress the scents, so that you would need like inks almost like that imprint all the different scents. You need to like compress the entire olfactory system to like maybe you want to have a maximum of like 150 vials. That's like